Okay, hello everybody. Welcome to TechHead 2010. And let's see what we have today. This is going to be our agenda. Okay, I'm going to discuss on the slow logon issues. Okay, suffering from long login times, and basically what I'm trying to do here is I'm trying to give you information about one of the program what we have is called as WD-Wrap. Okay, and this WD-Wrap is Windows Desktop Risk Assessment Program. Okay, what we do is we go to the customer's place and we run the tool and we gather the data. We collect all the logs from your workstations and we analyze you're following the Microsoft best practices, where you have problems, all that. Okay, and everything is automated. Okay, especially if you use a Windows 7, it's just a button touch. If you use a Windows XP, you just have to copy the files, run the command, and put it back to the tools machine and all that you have to do. Okay, so what I'm trying to do here is, okay, I'm just trying to show you one part of the WD-Wrap. Okay, by using the WD-Wrap, okay, how much you can improve the system performance. Okay, I'm going to discuss on the user logon process. Okay, and user ENV analysis. Okay, anybody have done a user ENV log analysis here? That's good. Okay. Then I'm going to talk on the Windows Performance Toolkit. Windows Performance Toolkit was released after the Windows Vista, but we can still use the Windows Performance Toolkit on Windows XP to collect the logs and then read the logs on the Windows 7 or Windows Vista machine. Okay. And yep, everything is demo. Okay, I'm crossing my fingers. Okay, to create a problem environment here. And yeah, hopefully, if it works, we should be seeing a kind of real-time environment. Okay, but if it don't, well, I'll try to run through a couple of logs what we have collected. Okay, all that. My name is Maha. You can call me as Maha. My full name is a very big name. Okay, and I'm a premier field engineer. Okay, my job is that I'm a field engineer. I go to the customer's place. I work with the customer. I educate the customer. I do both proactive and reactive. Okay, I do risk assessment programs like AD-Wrap and WD-Wrap, all those things. And I'm based in New Zealand, and I'm in Wellington actually. Okay. So why the performance is important from the start? Okay, performance is really important. Okay, why is the productivity? Okay, how do you measure the productivity? The productivity is measured, it's a ratio of output based on the input, how much input you had and how much output you got. Okay. When the productivity comes, actually everybody thinks, the whole management thinks, okay, how is our organization is doing with the productivity? Okay, how is our network reliability? How is our redundancy on the servers? Okay, everybody talks only on the servers and the network side. Okay, nobody thinks more on the workstation side. Okay, I know few people actually does that, but if you take an example, like we have delivered the WD-Wrap, okay, for a lot of customers. Imagine, okay, we have one of the call center in the Philippines, and the users actually they have 1,000 users in the call center. In the call center, what happens is the more the number of you take the calls, the more the revenue they get generated, right? So these users actually they come in and they log into the workstation and it takes 5 minutes for them to log in. Okay, so we told them that go for the WD-Wrap. Okay, and they did the WD-Wrap. Okay, they expected the improvement to come at least 10% improvement. Okay, but the improvement was more than 50%. Okay, so what happened there was more than 100%. I would say. Okay, we are able to identify what are the things actually was causing the slow logon issues and all that. We fixed everything, and you don't believe the logon time now it's taking only 2 minutes. Okay, because they have so many applications, the telecom applications and all that. Okay, with all that we are able to achieve only 2 minutes. So how much we saved here? The 3 minutes. Every user is saving 3 minutes. What does it mean is, if you take 1,000 users, right? And you are saving 3 minutes per user, so how much is going to be? It's going to be a 3,000 minutes. Okay, so you have saved 3,000 minutes per day. Okay, it's going to be almost how many? 50 hours something? Yeah, it's going to be 50 hours. Okay, so the productivity is not only from the server side. We need to think about from the workstation as well. Okay, I know we are taking care of our Active Directory, our servers, Exchange, everything. Okay, we also need to think about the workstation side. Okay, usability also comes as a part of performance, because if the system is very easy to use, okay, the application is not crashing. Okay, so the usability really matters, right? So if a system is very easy to use, the user will be happy. Okay, then comes the scalability. Okay, scalability is the ability to extend the system. Okay, like a memory, adding a memory. Do we need to add a memory? Okay, do we need to go for a new application? Does my system can take a more application? Okay, how much memory it has got, how much hard disk capacity it has got, how much CPU it has got. Okay, so should I go for application installing on my system itself, or I should go for a application virtualization? Okay, so all this is part of a scalability, okay, which also gives a system performance improvement. Okay, and scalability is always directly involved with the cost. So if all these three things are good, okay, we can see the happy customer. Okay, so let's talk on the WD wrap. Okay, Microsoft Windows Microsoft Services Risk and Health Assessment Program for Windows Desktop wrap. Okay. The common areas what we have found with our customers is system unavailability. Okay, the system is crashed, system is rebuilding, the system cannot log in. Okay, it takes a lot of time to log in, all that. And system is crashing. Yeah, we know that. Okay, it's not we actually. Our drivers actually crash the system. You get a blue screen, but we want to save our DLLs. That's the reason we crash the system. Okay, why did that crash happen? It's not from us. It's because of the third-party application actually maybe trying to do something with our memory area. Okay, or trying to use the CPU, IRQ or IRQL. Okay, all that. We have seen a slow startup and performance. Okay, we have seen many cases, and application compatibility and vulnerability. Okay, all these are the main common pain problems of any of the organization. Oh, what does the risk assessment program does? Okay, the risk assessment program is not just we have prepared it. Okay, it's analyzed. Okay, what we have done is we have implemented it in our Microsoft IT itself. Okay, and also we have gathered all the customers' experiences. And what this risk assessment does is we have hundreds and hundreds of rules. Okay, it checks all the systems and compares the rules. Okay, and it gives you a red light or a green light saying that. So GUI tells you saying that okay, the systems are good or systems are bad. Okay, and it is action oriented. It is not just like I come to your site and I run the WD wrap and I come back and say that this is your report. You take this report. No, it's not like that. Okay, I come to your site. We analyze the logs. Okay, we analyze the logs in front of you. We show you how do we analyze the logs, and we fix the issues and we show you the performance improvement from last time. How much it is now? How much improvement it is. Okay. We also does the knowledge transfer while doing a WD wrap. Okay, and it is delivered by the highly experienced and accredited Microsoft engineers. Okay, this is not available from the partners. Okay, just to highlight. So what I'm doing here is I'm just trying to make use of one part of the WD wrap program, and I want to show you how can we implement the logon process and the Windows startup process, all that. Okay, so how does the logon process happens? Okay, if you want to know the logon process happens, if I want to start, we need to know about the group policy processing. How does the group policy processing happens? Okay, we need to know how is the group policy. What are the group policy components? We need to know about WinLogon. We need to know about user env, group policy engines, client-side extensions, all these things. Okay. So let's take a look at the group policy components. Okay. So group policy object. When you create a group policy object, you go to the GPMC, you create a group policy object. The group policy has got two components. Okay. A GPC and a GPT. Everybody knows. I hope everybody knows about this one. Okay. So the GPC is created in the Active Directory. Okay, and the GPT is created in the sysvol. Okay. So when you create a GPO, again, we are going to create two things. It has got two components. One is GPT and GPC and a GPT. Okay. The group policy, actually, if you create a group policy saying that Internet Explorer policy, it's a user-friendly policy for us, actually. Okay. The system does not understand that the name of the policy. Okay. My computer, my domain controller all knows the group policy with the GUID name. Okay. So let's take a look at here. Let me go to one of my domain controller here. So if you see here, I have a default domain controller policy, and in the default domain controller policy, the GUID of the default domain controller policy is a 6AC. Okay, it starts with the number called as 6AC. Okay, so now I told you that group policy object is divided into two parts. One is a GPC and GPT. Okay, let's see where is the GPC. The GPC is in the Active Directory. So how do I see that? I go to ADSI edit, okay, I go to the system, go to policies, okay, see here GPC, group policy container, okay. So the GUID what we are looking at here is the 6AC, okay. So if I right click and see this is the group policy object, this is one of the Active Directory object, every object has got its own attributes. I go here and I can see all the attributes of the group policy. Okay, the most important for me here is the display name here. Okay, and there are some things actually. The group policy container points where is the group policy template is. Okay, I can show you here. This is a GP file syspath. Okay, the GP file syspath tells us where is the GPT is. Okay, so what is there in the GPC? What is there in the GPT? When you create a group policy, you created a group policy in the domain. You can create a group policy in the site on the domain level, okay, or on the client machine itself, local security policies, or you can create a group policy on the OU, right? So when a user is trying to log on, okay, what we do is we query the Active Directory to find out which group policy the user has to get. Okay, once we get all the information from the Active Directory, then we go here to this particular path. Okay, which is nothing but my sysvol, okay, and here we go to the sysvol, and here is a contoso.com. If I go inside the policies, and here is the 6AC. Okay, this is the GPT. Okay, so the GPC is stored in the Active Directory, GPT is stored in the sysvol. So it is very important for us to make sure the AD replication and the FRS replication are working properly. Okay, and so here's the OU actually. If I go to the domain, okay, if I go to the domain, I go to the properties, okay, and you can see the GP link. Again, GP link tells us our best is go for here, the default domain controller policy, okay, and default domain controller OU, sorry, and here is the GP link. Okay, you can see here our users or a domain controllers in this particular OU should get the group policy, which is this. Right. So what it does is, okay, it tries to query this one, the GPC path. If you see the LDAP path here, where is this one is stored? Okay, when a user is trying to log on, we do all this. Actually, we try to query here, and we identify the user has to get this group policy. Then what we do is we just go to this path and to identify where is the GPT of that particular group policy. Then we go to the sysvol and we gather the data, so the GPT data, and we take it and we apply it to the system. Okay, this is all about the group policy. Okay. Group policy has got group policy is a very big component. I try to make it short and try to explain you in a very short. Okay. group policy container, group policy template. Okay, GPC is stored in the Active Directory, GPT is in sysvol. So what happens when the user is trying to log in? Okay, when the user is trying to log in, you get a screen, Control-Alt-Del screen. Okay, that is in Windows XP, it is called as MS Gina. If you are using a Microsoft Gina, it's called as MS Gina. You put a username and you put a password. If you select the domain name, you hit enter. Okay, the credentials, whatever you given, they get hashed. And they will be passed to the process called as WinLogon. Okay, they'll be passed to the process called as WinLogon. WinLogon sends that credentials back to the LSA, and LSA checks if the user is a local user, if a user is a domain user. Based on that, if a user is a domain user, it works with the SSPI engine and forwards the credentials to the nearest domain controller, okay, for authentication. Okay, if a user is a valid user, Active Directory tells, okay, allow the user to log in. Okay. Now the WinLogon, what it does is it allows the user to log in. So WinLogon is the main context for us. WinLogon is the main process which is going to take care of the user is going to log in completely. Okay. What WinLogon does is once it says that, gets a confirmation that user is a valid user, it calls another process called as user env process, user environment. Okay. So what the major job of the user environment is to load the profile, a temporary profile or a roaming profile or a mandatory profile, whatever the profile the user has got, its job is to load the profile. Okay. Once it finished loading the profile, it calls the group policy engine. In the group policy engine, we have got something called as RSOP, resultant set of policies. Okay. The resultant set of policies goes to the Active Directory, okay, and it queries the Active Directory which group policies the user has to get. Okay, it checks site level policy, domain level policy, OU level policy, which policy the user has to get. It comes and tells the client system saying that user has to get this GUID, this GUID, this GUID. Okay, then the system goes to sysvol, takes those GPTs, and with the help of the CSC is nothing but a client side extensions. Okay, if you see the Windows XP, in Windows XP we hardly have 8 client side extensions. These are the DLL files which helps us to apply the group policy. Okay, so these client-side extensions make sure that the group policy is applied. Okay, then we initialize the user init process and we call the explorer.exe. Okay, so user gets a desktop. Okay, this is the basic logon process. Okay. But for a troubleshooting for the logon process, this is not just this information is really not enough. You need to know more about the boot process, okay, and so many other components. Okay, so here's the boot process. This is very, I would say, if I want to explain you about this one, let me see. Okay, what happens if you switch on the computer? When you switch on the computer, the BIOS takes the control. Okay, the BIOS takes the control, and what BIOS does is it does a post check, power on self-test check. Okay, so what it is doing in the post check is it is trying to identify what are the devices are connected to the motherboard. It checks every device connected to the motherboard, the CPU, the memory, hard disk, everything. Okay, if everything is okay, then what it does is it goes and tries to load something called as master boot record. Okay, master boot record is always stored in the sector 0 of the hard disk. Okay, so it loads the master boot record into the memory execution area. Again, the master boot record contains two things: boot execution code and a partition table. The boot execution code, what it does is it looks into the partition table and it identifies that which partition is the active partition. Either C drive is active partition, D drive is the active partition, all that. Okay, it identifies which partition is active partition and it loads that partition. In Windows NT, so in Windows NT 4.0, what is that partition actually called as? That partition, what the information stored in that particular partition. In NT4, XP, 2000, 2003, we all use even Windows Millennium. Okay, we use the same Windows, we use the same boot process. So in XP, if you take example of XP, the active partition first sector, what it contains is NTLDR. Okay. NTLDR gets loaded and NTLDR looks into the boot.ini file, it's a boot.ini file, to identify where is the operating system is stored, and looking at the boot.ini file, it calls the operating system. Okay. If you have a legacy operating system, then we call the boot sector.dos. If you don't have legacy operating system, we call ntdetect.com. ntdetect.com will come and detect all the hardware, okay, and then we call the NTOS kernel. Okay, so this is a long process. But in Windows Vista onwards, we have made the boot process very simple. Okay, so in Windows Vista or Windows 7, what we normally do is you switch on the system, BIOS takes the control, BIOS does all the post check, okay, and it looks into the, if everything is okay, it loads the master boot record. Again, the master boot record boot execution code loads the first sector of the active partition. In Windows 7, what is the first sector of the active partition? It's going to be boot MGR, okay, called as a boot manager. Okay, boot manager looks into a file called as BCD file, boot configuration database file, and if you have shut down the system, it calls the winload.exe. If you have set the system to hibernate or sleep, it calls the winresume.exe. Okay, so this is actually the boot process in the background. Okay, but here is the picture actually. Okay, what happens here is, okay, here's a BIOS. When you switch on the system, okay, BIOS gets initialized. Okay, the BIOS gets initialized, does the post check. Okay, this is how the actual boot process happens. The BIOS gets initialized. Okay, and here we call the winload.exe. Okay, winload.exe comes here. Okay, what winload.exe does is it loads the registry to the memory. Okay, and also it loads the required important drivers into the memory, like a display drivers, network drivers. Okay, all those the important drivers will be loaded here. Once that is done, okay, we have a main path boot. Okay, everything happens here. We have divided the sections into these 4 parts. Okay, and again the main path boot has got again the sub parts. Okay, and what happens here is once the winload finishes loading the registry and loading the required drivers, it passes the control to the kernel. Okay, so here what kernel does is here, okay, it initializes the registry and loads all the required the actual drivers and all that it does in this phase. And once it finishes, here is where it calls loads all the services. Okay, once the service everything is loaded, the service control manager calls the winlogon. Okay, once the winlogon comes in, that the user is trying to log in. Okay, all the login information happens here. Okay, user gets a explorer.exe. Exe means that user is going to get his shell, his desktop. Okay, once the user has got a desktop, okay, we still work on the phase which is called as a post boot phase. Okay, this is the explorer.init. Okay, here actually what happens is in the post boot, what happens is we load the applications like, especially the most important one is the antivirus. Okay, we load all the startup applications of the user. We load everything in the post boot. Okay, even we have found the explorer.exe here, but most of the time the system is not ready to use. Why? We are loading the startup applications. Okay, I have seen many of the customers, especially here, they all use the Nokia software. Okay, and the Nokia actually runs as a startup applications. It's one of the startup application. Okay, when it is coming up, it makes the system slow logon. Okay, you can launch the Nokia application later as well. You don't have to call the Nokia application at the beginning itself. Okay, try to minimize the applications, the startup applications, okay, so that your system, the user can get the system performance faster. You can see the system is booting faster. User logon is faster. Okay, we looked into the GPU already. Okay, the tools to analyze the user logon these are very simple tools. Okay, event viewer, okay, user env log, and WPT is a Windows performance toolkit. Okay, earlier we used to call this as an XPerf. Okay, so now it's a Windows performance toolkit. Okay, and we also have a process monitor. Okay, it's called as ProcMon. ProcMon under WPT, they analyze the whole system startup. Okay, they just don't we cannot use them for just a logon purpose. Okay, user env log, you can use it for a logon purpose as well as a computer startup. Okay, So here is a sample user env log. Okay, if you see this user env log, what do you think? Okay, everything. If you're looking at the user env log for the first time, it's just like stars actually. Okay, you will not be able to understand anything out of it. Okay, everything is a numbers, hexadecimal, and all the stuff. Okay, all the codes and all that. Okay, if you really want to work on the user env log, okay, you need to get a hook of analyzing the user env all the time, so that again and again, so that you get used to analyzing the user env log. Okay, so the information for the user env log is, here's one of the KB article, which is 221833. Okay, it tells you that how to enable the user env log. Okay, and we do have some of the blogs which tells us that how do we read this user env log. Okay, from where I need to start. Okay, from where to where I need to end. Okay, so we do have blogs which tells us that how do we read the user env logs. Okay, so let's take a look at the user env log. Okay, and here is the XP machine. Okay, how do I enable the user env log? Is I go to the registry, regedit. Okay, and if you go to the HKey local machine software, okay, Microsoft, okay, Windows NT, okay, current version, and here's a WinLogon. Okay, so in the WinLogon, what we do is we right click here and we create a dword value, which is user debug level, and it is a case sensitive. Okay, the U, D, L should be uppercase. Okay, user env user debug level. Okay, and I am going to set the value as 10002, which is going to be a high logging for me. Okay, and where is the log file? I enable the log, but where is the log file? The log file is stored in the computer C drive, Windows. It's a debug folder. Inside the debug, I have a user mode. Okay, and inside the user mode, here is a file called as user env file. Okay, now what I will do is I'll just right click, I'll select all. Okay, and I'll just delete everything. Okay, because I want to create a new user env log, and I just want to go through how do we analyze. Okay, so I'll just log off from here. Okay, I logged off as administrator. And now I'll try to log in as a user who is having a problem. He's having a slow logon problem. Okay. Oh, he don't have a slow logon. Okay, it's logging on. So if I take a time, okay, if I take at least 5 seconds before that, it's going to be 45 or maybe 40 seconds. Let's see how much time it takes to log in. So the user is logged in. 40 plus 20 plus 20 is almost 45 seconds or something. Okay, the user took some time to log in. Okay, I have cut short this one. Otherwise, I can make the user to log in for 5 minutes sitting idle. Okay, but simply we will be just killing the time. Okay, so here is the user is logged in now. Okay, let's go and see what was happening in the background. Why the user did not get the desktop. Okay, I go to the log file, which is in the C drive, Windows, debug, okay, user mode, and oh, it's just a 1 KB. What happened? I think I missed the registry value something. I hope we should be able to capture something this time. The user is logged in here, so okay, I go to my computer, I go to still it is doing something in the background. If you see here, the mouse is doing something. So this is just a virtual machine. It does not have any applications and all that, so it's faster actually. But in the production systems, the user gets a desktop, but he cannot do anything. He cannot move the mouse and all that. Okay, so let's go inside the C drive, Windows, okay, and debug user mode. Okay, here I got some data here. Okay, let's go and see what is happening. Oh. Just to make it bigger. Okay, so you can see here the user 1, the name of the user is user 1. The user 1 started logging in, right? And what time he started to log in is at 14:39. Okay, it even gives a fraction of seconds, 752. Okay, let me open one more notepad file here. Okay, so I note down this one as, okay, the logon is started at this time. Okay, so and once the user is logged on, you can see here the winlogon. What it is doing is it is the winlogon process. Okay, in console winlogon process is loading everything. Okay, and the job of the winlogon is to call the user env. Okay, what is the job of the user env is again loading the user profile. Okay, so what we are doing here is we load the user profile. Okay, so no local mandatory profile is defined. Okay, and here is the user hive. We load the user hive, and once the user profile is loaded, okay, as we discussed earlier, okay, we are going to call the group policy engine. Okay, you can see here we started the group policy engine. Okay, so group policy engine, we initialize the CSEs, client side extensions. We initialize the client side extensions here. Okay, and once we initialize them, we are going to do the RSOP check. The user has to get this group policy, this group policy, this group policy, all that stuff. Okay, so once we identified that user has to get this, okay, then we go and process them. We go and get the group policies from the sysvol, okay, and we will then process the group policy, okay, from the sysvol. You can see here. Okay, where we are querying here is this is an LDAP query. We are looking into the Active Directory, and here is where we are looking into the sysvol. Okay, so here is a version number, GPC and a GPT. So what Microsoft has done is, since we have created the two components. When you create a group policy object, it's a GPC and a GPT. We might get a mismatch. We might go for a version mismatch. So we don't want to get a version mismatch. What we do is we have created something called as a version number. Okay, so here actually we check the version number. If the version number are not matching, okay, if the version number are not matching, the Windows 2000 computers don't get that group policy. Okay, XP can get a group policy, but the logon will be very slow. Okay, so here actually we analyze, okay, what is happening in the background, okay, all that stuff here. Okay, so here also a lot of group policies are getting processed. All the CSCs actually they are making sure that the group policy is being processed. If I have IE group policy, the IE DLL would have taken care of this group policy here. Okay, so everything goes on here. Okay, and what we normally do is, okay, if you see here, the user init is being initialized here. Okay, and Windows Update Agent is coming up here. Okay, and then we finally look into the Windows Explorer. Okay, so I would assume that, okay, the user logged on at this time. Okay, if I go in here and here, if I check how much time the user took to log on, is this minus this. Okay, so this is not just an, we cannot just leave it here. What we normally do is, okay, why the user took so long? Okay, how much the user took here is 39, means if I keep it as 40, this is going to be 21 plus 17. Yeah, 21 plus 17, how much is going to be? 8 and 30, almost 39, 40 seconds user took to log on to get the explorer.exe. Okay, so what was happening here is, okay, I'll just go back here and see. Okay, but actually user was able to use the desktop. You can see here, I was able to go and open the notepad, which is nothing but my user env log. I double click the notepad, it even captured that as well. Okay, so now my job is to identify where this delay happened actually. Okay, so I'll start going through from the beginning. Okay, I need to look into the seconds actually where it is getting jumped actually. Okay, so the user was trying to log in here and everything is going good here. Okay, and there's no lot of jumps here. Okay, everything is going smooth. Okay, then he reaches the 41 seconds. Okay, this is normal because here he's reached the high level. Okay, and coming down. Okay, and here is a little delay. If you see here, the fraction of seconds delay because when the group policy was getting initialized. Okay, so that's, we can ignore that one. Okay, and then going on here. Okay, and here is something happening. Okay, everything looks cool for us, right? We don't see any issues here because normally, if I would have set the slow log on for at least for 2 minutes or 3 minutes, okay, we would have seen some information. The group policy was taking so long. Okay, so what we have very good information here is this is the process ID actually. Okay, this is a very good information for us, but this is a process ID which is in the hexadecimal value. Okay, so I can easily find out if I see that, okay, there is a 42 to 46. Okay, this here is a problem actually. Okay, there's Windows Update agent was doing something. It took 6 seconds to launch. Okay, which is normal because if you in the production environment, if you are doing a lot of deployments when the user is trying to log on, okay, the Windows Update agent will definitely take some time. Okay, it has to pull the software and it has to deploy the software and all that. Okay, basically, if you see the hot fixes for the Windows Update agent, you will find a lot of hot fixes because we are actually in a process of improving the Windows Update agent. Okay, so this is how actually we go through the user env log. Okay, I just want to give you a heads up on this one, user env log. Okay, the tool I was talking about, a tool, WDWrap tool. What it does is it analyzes everything automatically. Okay, it tells you that what is going wrong. Okay. So this user env log, okay, is only available with Windows XP. Okay, this is not available in Windows 7. Okay, so the whole Windows 7, Windows Vista, and Windows 7 architecture has been completely changed. Okay, in Windows Vista and Windows 7 onwards, we don't use a user env file. We use a different tool called as Windows Performance Toolkit. Now we call it as a Windows Performance Toolkit. Earlier it used to be called as Xperf. Okay, so let's go back here, and we looked into the user env logs. Okay, and here is the Xperf. Okay, what we should, I'm not going to talk on the Xperf architecture here because that's going to be a very big topic. What we can do with the Xperf? Okay, we can find out if there's something happening and you are not able to see that. Okay, like I don't know what is happening in the background. Okay, the system is taking long time. Okay, you can check that. Long delays in applications, you can find it out. Okay, high CPU usage, DPC, ISR bottlenecks. Okay, C switch, high disk usage. Which application is using a high disk? Why it is making its disk very high? Slow on off transitions. Okay, poor battery life. Okay, and much more. Okay, you can do so many things with the Xperf. Okay, so here is some of the switches we normally use for our purpose, for the logon purpose. What we use is we use the boot. Okay, for a shutdown we use the shutdown switch. We use a standby. Okay, or we use a hibernate. Okay, so even though if you see here, if I take a look at the user env log, what we saw here. we are not able to make out, okay, why there was at least so much of 30 or 40 seconds delay actually. Why is that delay was happening? Okay. So what I will do now, what I will do here is, okay, for the same user, I enable the xperf trace. Okay. So I go to the command prompt. Okay. And I'm calling it xboot mgr. Okay, xperf has got 3 exe files: xperf view and xboot mgr. Okay, you can do everything with the xperf. You don't have to use the xboot mgr, but using xboot mgr is very simple. So I'm just using xboot mgr. Okay, I want to trace the complete boot process, and how many times it has to run. I can define that. Okay, every time the system starts, it keeps on catching the logs. Okay, but here actually I set a number of runs. Actually, how many times it has to run, I'll set it as 1. Okay, and trace boot delay. Okay, so what this trace boot delay I'm doing here is, as we all know that when the Explorer got initialized, okay, but still the user is not able to use the mouse. Right? What was happening in the background? There are so many applications are getting launched. Okay, so what I'm doing here is I'm trying to set 120 seconds a delay, okay, so that don't finish taking the trace, means the log, okay, wait for 120 seconds, okay, then complete the log. Okay, so I'll give a 120 seconds here, then I say trace flags. The trace flags, I put a switches, like base, C switch. Okay, these are the different switches what we have. You can just do it for a CPU. You can just do it for a hard disk. Okay, you can just specify whatever you want. Okay, these are the 3 switches. Why I'm doing all the 3 is I want to capture more data for me. Okay, so when I hit enter, okay, trace boot delay is not recognized. Trace flags is already there. Which one? LAY? Oh, okay. No. Post boot delay. One is post boot delay and trace flags. Okay. So it waits for 5 seconds. After 5 seconds, it goes for a restart. So the user is logged in, but he cannot still use the system because there's something happening in the background. So this is what it is doing. Because I have set the post-boot delay to 120 seconds, it waits for 120 seconds till all the applications getting launched in the background. Okay, so this is very useful in the production environment because we want to know what are the applications getting launched. If you think that when the user logs on and the user gets a desktop only after 5 minutes, then you need to set the post-boot delay for 5 minutes, for 300 seconds. Okay, so it goes like in that way. Okay, it finished. Now what it is? It's compiling the data. Okay, and if I go inside the XPerf, okay, we were going to see here the ETL file. There is a ETL file. Oh my. Oh, okay, yeah. I started from here. Sorry, not from here. You're right. Good. Thanks. Okay, and I just copy this. I cannot analyze this ETL file here in the XP system. So what I will do is I'll just copy this ETL file to my base machine. It's not to play actually, this is to give the demo. Okay, so I got the ETL file now. Okay, I go to the command prompt and tech. Oh. Okay, so I use the XPerf view. Okay, and I should view this file in the XPerf view. Okay, so here is the log file. Okay, the XPerf view, XPerf actually is a very good tool what we have invented. Okay, after Windows XP, in Windows XP, in Windows Vista onwards, we started using something called as ETL files. We call it as a ETW tracing, event tracing for Windows. Okay, I will not discuss on the event tracing for Windows. Again, it's going to be a big concept. We have providers, data providers, consumers, okay, and controllers and all those stuff. Okay, this is XPerf is built on that ETW tracing. Okay, so if you see here, we can easily identify, okay, what the IO was the IO was very high. Okay, IO counts was very high. So IO counts are okay normal, and here is a disk. If you see the disk is going very high, which is normal. When the system starts up, hard disk is is spindled heavily. Why? Because we want to load all the drivers, everything into the memory. So it's going very high at the beginning. Now again it's coming down and it is working as expected. Okay, so it's not a problem with the hard disk. Hard disk is good. Next is a process. Okay, we have different processes here running here. Okay, I can just move my mouse as a SVC host and all that. Okay, and here is something interesting. Okay, and if I come here, you can see here. This is really good information what we have. Okay, I switched on the system here. Okay, and the system. Okay, the kernel, the system will get launched here. Okay, the WinLogon started here, and we started loading the spooler and SVC host services all got loaded here. The WinLogon actually came again here. The user init came, and when the user init came, we were wondering, right? Okay, the user can see the desktop, but he don't have a start menu. Something was happening in the background, right? So what was happening in the background? We could not identify that what was happening in the background by using a user env file, but here in the XPerf, we can easily identify what was happening. Okay. So there was a batch file which called the sleep, and it was sleeping for how many minutes, you can easily find out here. Okay, this is again the process ID. You can identify. You can find out. Okay, what are we doing here? Actually, this much time we are wasting, right? So let's go and see what is going on here. Okay, I just go and find out here. Say process summary table. You can see here I'm calling the whole process was used by the sleep.exe. Okay, the CMD was a batch file, and the sleep.exe, the duration was mainly used by these two things. Okay, at that point of time. Okay, and the XPerf is not an ordinary tool. Okay, it is a very vast tool. Okay, we can do so many things with the XPerf. It's not only for the boot trace. You can use it for so many other purposes. Okay, and we use this tool during the WD wrap, and we analyze the systems, and we tell you the exact data. Okay, if you see here, and if you see here, okay, the system is started at here at this point. Okay, so the system started here. The WinLogon was called here. Okay, and the sleep we went for a sleep. We would have saved this much time. Okay, if we would have get rid of if we can get rid of this batch file, and here the explorer.exe was launched. Okay, so how long it took to the system to start? Okay, from when it switched on the system, it took almost 88 seconds for the Explorer to get launched. Not 88 seconds actually. It took how much? Here, see here, it's 78 seconds. Okay, so we show you at the beginning, okay, how is your system right now, okay, and we also do the remediation, and we also tell you that, okay, how is your system now after the remediation, how your system looks like. Okay, and I have worked with so many cases on WD wrap. I've worked with so many customers for the slow logon and all that. When we ask the customer that, do you have a script? They say, oh, I have only one script. How many applications you launch? They say that I have some 1 or 2 applications, the startup applications. Okay, so nobody actually commits. Actually, this is one of the trays. I just want to. This is a sample actually what we have created from ourselves. Okay, see how it looks like. Okay. So the logon UI is a part of the Windows Vista machine. It was taken on the Windows Vista. So the WinLogon came here, logon UI, the user pressed the Control-Alt-Del, okay, he tried to log in, okay, and he was just calling a script, just calling a script. Yep. Yep. So these are the tools actually normally we use, and we achieve what exactly, how do we come to the solution, and we fix the issues, and we show you that how to improve the slow logon. Slow startup, everything. Any questions? The terminal services? Yep. You can use it on a file server. You can use it on a domain controller. You can use it anywhere. It works on 2000. It doesn't work on 2000. It works on 2003 and XP. it's a part of software distribution toolkit now. You can, if you download the latest software distribution toolkit, you will get the Windows Performance toolkit. And it's always every 3 months you see a new version. Every 3 months you see a new version. Thank you.